IoT based electrolyte bottle for healthcare. Our abstract of the project is during modern years, good patient care in the hospital, consideration and management of patient is the most fundamental thing required. In current healthcare measure, whenever electrolyte bottle fed into any patient, the patient needs to be continuously monitored by a nurse or any caretaker. Almost in every hospital, a nurse or caretaker is responsible for the monitoring the electrolyte bottle level continuously without any interruption. In a hospital, due to heavy workload, nurse forget to change the electrolyte bottle once it's emptied. It will bring a bad consequence to the patient. The air bubbles entering the patient bloodstream, which cause immediate death. Objective to overcome the drawback in manually controlled electrolyte bottle system to provide greater accuracy than manual glucose flow rate control system to stop the flow of the blood in the reverse once after a electrolyte bottle is empty. Domain introduction. Today internet application development demand very high, so IoT is a major technology by which we can produce various useful internet application. Basically, IoT is network which all physical objects are connected to the internet through network devices or router or exchange data. IoT allow object to control remotely across the existing network infrastructure. In existing system, it requires the caretaker of the patient to request the hospital staff to replace the little bottle. If the caretaker is not there, the nurse also not available, then blood will be flow in the reverse order. Disadvantage. The existing system need to be continuously monitoring. It causes the critical risk of the air bubbles entering the patient in bloodstream. Our problem statement. During recent years, due to the technological advancement, many sophisticated techniques has been involved for assuring the fast recovery of the patient hospital. This system also avoids the fatal risk of air bubbles entering the patient bloodstream, which is serious threat. Air bubbles in blood can cause immediate death. The proposed system is developed using Internet of Things. The proposed system monitored the critical level of the electrolyte bottle using IR sensor. Electrolyte bottle reached the critical level which is sensed by the IR sensor. This sensed output is sent to the microcontroller which scans the database for retrieving the content information and alert sent to the nurse or in the hospital. The electrolyte continuous message until the fluid reaches second level. Sending call alert. The fluid reaches the second level. It sends auto call by GSM. Call is sent from the GSM by inserting the SIM in the device. The call is sent from the device to the mobile device. Auto cut bottle. If the nurses fail to attend the patient to replace the bottle, the fluid flow will automatically stop using solenoid valve. We used this kind of test case: interface testing, validation testing, data integrity and security testing, efficient testing, and error handling routing. First, interface testing: mouse, tab, navigation, user friendliness, and consistent graphical button. Validation testing: check for improper or inconsistent typing, check for erroneous installation or default values. Data integration security testing: data insert, delete, update condition, overflow exception, and check for the unauthorized access to data. Efficient testing: throughput of the system, response time of the system, online disk storage, primary memory requirement of the system. Error handling routine: error detection are intelligent, understandable. Error recovery is smooth. All error handling routine are tested and executed at least once. This is our screenshot of the project kit. Our application view of the screenshot. Same as the screenshot of the application. This is a receiving call by our project kit. This is message. The conclusion is the IoT-based electrolyte bottle monitoring system reduces the manual effort and work pressure of the nurse. The complete proposed system is fully automated because it requires very less human involvement. It will reduce the stress in the respiratory monitoring by the doctor or nurse or any responsible cost. Our future enhancement is in future fluid level monitoring system can be done inbuilt of the electrolyte bottle. The system can further improve for multiple patients with single web application through which we can monitor the fluid status of multiple patients and control the drop rates remotely. This is our reference. This is our reference website. Thank you.
Our project kit. It's contain step down transformer, voice processor, big microcontroller, 3 IR sensors, IoT device, GSM, LCD display, electrolyte bottle, solenoid valve, and capacitor, regulator, relay. The system works on the principle of direct current, but we use alternative current in our home, so we want to convert DC into AC. First we use step down transformer which decrease 230 volt AC into 12 volt AC. This 12 volt AC step down to capacitor and it's convert into 12 volt DC. The regulator convert this 12 volt DC into 5 volt DC. Then we write the program into PIC microcontroller. We use 2 into 16 LCD display. This display consists of 6 characters per one line. This consists of 32 characters per 2 lines. The relay is used to control the solenoid valve. Next we use the voice processor. It is used to record the voice. The voice processor consists of amplifier, regulator and so on. Next we are using IoT board. It is convey the message alert. It is a Wi-Fi module. It does not work with net. Next we use GSM module. It is send call alert to nurse. The GSM consists of the SIM card. The call will be conveyed by the use of SIM card in mobile device. The 3 IR sensors are used to sense the fluid levels of glucose. If the fluid level cross the first level, it send message to concerned nurse with room number. Next, the fluid level cross the second level, it send an auto call to the nurse until it cross the third level. Then the nurse attend the patients, then replace the bottle. If the fail to nurse attend the patient, this system will be stop the fluid automatically by using solenoid valve. Electrolyte bottle for healthcare. Let's start our project demo. In power supply given to the board. After giving power supply, flow will get. Reduce the glucose level. Level 1 crossed. After message will be sent. Received message. Then second level crossed. If second level crossed, continuously call will be sent until third level reached. After reaching the third level, it will be get auto cut.